Today, we're diving into one of the weirdest and most amazing experiments in all of science. Seriously, this is a mystery that completely changed how we think about, well, pretty much everything.
So let me ask you a question. A tiny little speck of something. Is it a solid ball or is it more like a ripple spreading out in a pond? It sounds like a strange question, but what if I told you the answer is both? Let's set up a really simple experiment to see how that's even possible.
Okay, to get to the bottom of this mystery, we only need 3 simple things. Let's get our experiment all set up.
First up, we need some kind of shooter, something that can fire really tiny things one at a time. Next, we put up a wall, but this wall has 2 little slits cut into it. And finally, we have a screen at the back that'll light up and show us exactly where those tiny things land. A pretty simple setup, right?
All right, for our first clue, let's start with something we all understand really well: waves. Just imagine ripples in a pond. What do you think happens when those ripples hit our wall with the 2 little openings?
Well, as a ripple passes through those 2 slits, it's like 2 new ripples are born, one at each opening. And as they spread out on the other side, those 2 new waves start to overlap and mix together.
And here's where it gets really interesting. When those waves mix, they create this very special pattern. You don't just get 2 bright lines on the screen. Nope, you get a whole bunch of bright and dark stripes. That's because where the waves meet, they can either add up to get bigger or they can cancel each other out. We call this an interference pattern, and you have to remember this. It's our first big clue.
Okay, so that's what waves do. But what if we switch gears and shoot tiny little balls, particles, at the wall instead? We're going to use something super tiny, like an electron, and fire them just one at a time.
Now, common sense would tell you that each tiny particle should just go through one slit or the other one, kind of like a tiny little paintball. So we should just see 2 simple lines on the screen right behind the slits. That makes sense, right?
Well, get ready, because this is where everything gets really, really weird. What actually happened didn't just surprise the scientists, it completely shocked them and turned the world of physics upside down.
You're not going to believe this. Even though we're sending the particles one by one, they slowly build up that exact same stripy pattern that the waves did. But how? How is that even possible? Each particle is flying all by itself, so what in the world is it interfering with?
The only explanation is kinda mind-blowing. It's as if each tiny particle acts like a wave, goes through both slits at the same time, interferes with itself, and then finally hits the screen as a single dot. I know, it sounds totally wild.
So of course, the scientist who saw this said, wait a minute, no way, we have to see this for ourselves. So they decided to put a tiny little detector right by the slits to find out which one each particle was really going through. And that's when the mystery got even deeper.
The moment they started watching, that stripy wave pattern completely vanished, just gone. As soon as they looked to see which slit a particle went through, the particles stopped acting like waves and went back to behaving like simple little balls, making just 2 plain bands on the screen.
This is the craziest part. It's like the particles are shy or something. The very act of looking at them, of measuring them, actually changes what they do. It's almost as if they know they're being watched.
So after all these strange clues, what does this actually tell us about the world? About what everything is made of? What have we really learned here?
Well, scientists came up with a name for this incredible idea: wave-particle duality. It just means that tiny things, like electrons or little bits of light, aren't just little balls, and they aren't just waves. They're mysteriously and wonderfully both at the same time. So, let's quickly recap what we found out. Tiny bits of light and matter can act like waves. They can also act like particles. And just by looking at them, we force them to choose which one to be. The takeaway is that the super, super tiny world is just way, way weirder than the world we see around us every day. And that leaves us with one final, huge question. It's a question that scientists are still trying to answer today. If looking at something changes what it does, then what are things really doing when no one is looking?
For more scientific videos, subscribe to our channel, 4 Corners of Science.